I'm going to get started here, and I thought I'd start off since we've got a lot of probes that are looking at our solar system that are in orbit or flying by some of the smaller items. I thought I'd give you a little bit of recap on some of those, and I'm going to start off with the Rosetta Mission. The Rosetta Mission is gone to a comet, and it's actually landed a lander on it as well, which took some data when it first landed. We had heard a little bit from the Philae lander, but I think Steve Lee probably reported on last time. It still has not come back into communication, so hopefully that will still do that. The Rosetta mission is around this particular comet in orbit, and this month represented the time at which it got to its closest approach, or what we also call perihelion. So you can see over here, it rendezvoused with the comet here in August of 2014, basically about 1 year ago. So it's been 1 year since it's been in orbit around the comet. This is when it sent in the Philae lander here. And here's where in this month on August 13th, I believe, it was at its closest approach. So comets are in these elliptical orbits. And when they're going around in these elliptical orbits, they move very, very quickly when they're close and slowly when they are far away. So they kind of zip by and spend most of their time here in the outer regions here. Now, when it's closer is when you have more radiation from the sun. And you can see there's quite a bit of difference between this distance and this distance in its furthest point when it first actually got to it. And it actually goes as the square of the distance. So this is probably, I think this is on the order of 5 times further, meaning that it's about 25 times brighter, the intensity of the sun, when it's actually in this position. So anyway, they were starting to monitor activity, and it did indeed have some active moments here. So here's a panel of 3 images. We'll look at them one by one here, of a period of few hours before this closest approach. And you can see, when it's, well, go ahead there, when it is actually starting to get close and heating up, it is basically exhausting these gases and blowing material back off into space here. And here's a fairly big outburst right there. And right here. And then this was an image that was taken about a day after perihelion, and they often call this the rubber duck. But I'm starting to think it looks more like Santa's boot. You know, he must be flying a little high, and he lost his boot in space here. But that's a pretty cool image there. And these are just taken by the NavCans, so they have better resolution cameras. And they released another image this month, in celebration. It's been 1 year around the comet, and this one I think was taken. So here's a animation of that closest approach, and you can see that jet image as it goes through. So obviously they're not taking a video here. They're taking images every I can't remember, few hours or so. And then another thing that they saw here as they got close is this basically boulder that got launched off the surface of the comet. Remember, there's very, very little gravity on this. In fact, it's pretty hard to actually even maintain orbit around such a small body that has so little gravity. And here's an image that they had released, I think, from the last January time frame, of looking into that saddle of the kind of the neck there, and it's just very cool. Now, they haven't, they've been releasing images and things like that, but they haven't talked a lot of science in terms of what they've been finding with their other spectrometers and things on this mission. And I think they're probably, all tied up in, the fact that they were at the closest encounter. And then the mission is essentially over in like December. Just like other missions, they'll go as long as they can because they are in orbit around that comet. And they eventually do run out of fuel to maintain that orbit. Okay, the other spacecraft that we have in the asteroid belt is the Dawn mission, and it is going around Ceres, which is the largest asteroid in the asteroid belt. It had visited Vesta, and it is now in a fairly close orbit where it's returning some of the best imagery of this asteroid.
This is dwarf planet Ceres, a mysterious world of rock and ice. How can you not be mesmerized by those glowing spots? We'll see those again in a moment, along with some other amazing sights on this fascinating alien world, revealed by the Dawn spacecraft now in orbit there. And get your 3D glasses ready. Here we're taking a little tour around a 60-mile diameter crater named Okator, a Roman agricultural deity. It's 2 miles deep, and you can see these intriguing bright regions. They reflect a great deal more sunlight than the rest of the surface material, but scientists haven't yet determined what it is about their composition or structure that's responsible. There are a number of different ideas about what they are, but to discover their real nature, we need to get more data from lower altitudes. Eventually, however, as we learn more about them, they may provide insights into the geology of this complex dwarf planet. This mountain is among the tallest features on Ceres, a cone that juts 4 miles high from an otherwise unremarkable area. It isn't in a crater or even obviously associated with one. So what forces shaped it? And why does it have this varying appearance, dark on one side, and now we're coming around to the other side and we can see these bright streaks running down one side? What does this structure tell us about how this world works? This is another of the captivating mysteries about Ceres.
One of the features that they were looking at was this one, which they had done a little 3D tour over here, which they called the Lonely Mountain. And it's a very interesting feature here. It's very steep along these areas here. That's peaked right here. It's light on this side here with these very interesting braided structures out here. As they said in the video, they don't know what it is yet. And it's not a crater. It's not associated with a crater. And yet it's this little wart or something on the surface there. So it's a very interesting feature. And so that's one of the ones that they'll be studying. And you can see the fairly high resolution. They're about 1,000 miles above the surface right now. And they've got about 1 mile resolution on the surface itself. 1 mile per pixel resolution. Okay, and then Pluto. There's not too much to report on Pluto. Of course, last month, Steve Lee talked about the encounter there. So I don't know if he had showed the video where they reconstructed the whole flyby of Pluto here, and I'm going to show that video. So one of the images that they did release this week was probably the best image we're going to see for Pluto for a little while here. They compiled 3 of the LORRI images along with color information from the Ralph instrument there to produce this color composite of Pluto. And so it is gorgeous. And in fact, we never had a view of Pluto before this last month. It's just an incredible thing to me. Hopefully we'll get up on our Science on a Sphere at some time here, if it's not already up there. One of the amazing things about this image and what it's telling us in terms of what they've learned so far is that, Pluto looks like to be an active planet. I mean, it's got its meteorite hit impacts and things like that, but there's definite indication that there's some sort of geologic type activity going on there. That's got a nitrogen atmosphere, which is strange in the sense that it should not be able to hold that on. So that's another indication that there's geologic activity going on that's being replenished there. And so they're working on the details of that. So some of you might know that the data from that encounter is just trickling in at like old modem speeds. So it will take a while before they get the higher resolution data from that. And they do broadcast it at where it's somewhat compressed so that they get some of the data and everything. But the ultimately best resolution data is going to be taken over the next months to, I think, about a year and a half is what it takes to get the whole data set off of there.